Welcome to Study Loop.
So in this problem, we are given a diagram which represents the reaction mixture, and the reaction here which is going on is A2 in gaseous condition reacting with 2B, which is also in gaseous condition, and they are in equilibrium with 2AB, which is also gas. Now, in first part of this question, we have to calculate the equilibrium constant Kc for the reaction. The volume is given as 2 liter, and we have to find out the value of Kc. So first we have to write down the expression for the Kc, or the equilibrium constant, for this reaction. So the expression for Kc will be the product concentration over the reactant concentration, and since we have 2ab, 2 will go as a power here, and in the denominator we will have the reactant concentration A2 and b whole power 2, since we have 2b. So this is the expression for Kc for this reaction. Now we have to know the concentration for each of the product and reactant. So to find the concentration is basically the number of moles over volume. So we know the volume here, but we have to know the number of moles. So if we assume that each of the molecules given here as 1 mole, so we can see that from here. If we assume the red ones as A2, so we have 2A2, and if we consider the blue ones as B, we have 2B, and we have AB is this red and blue mixture one, so we have 1, 2, 3, 4 of AB. So first we calculate the number of moles for AB. So since we have 4AB, that means number of mole for AB will be 4 mole, and from here we can find the concentration of the AB, which will be the number of moles over the volume, which is 2. So the concentration will be 2 mole per liter, or molar. And similarly for A2, since we have 2A2 here, that means the number of moles for A2 is 2, and the concentration will be 2 mole over 2 liter, that means 1 mole per liter, 1 molar. Similarly for B, we have 2B, that means 2 mole over 2 liter. Concentration of B is also 1 molar. So now we know the concentration of each of the reactants and products. We can just plug in these values here to find the value of Kc. So AB concentration is 2, that means 2 square, and in the here the reactant concentration is 1 times 1 square, that means we have 4 over 1, that means the value of Kc for this reaction is 4. So 4 is the value of Kc for this reaction. Now the second part of this problem, we have to find out if the volume is decreased, if the number of molecules of AB will increase or decrease. So the volume decrease means pressure increase. So according to the Le Chatelier principle, the equilibrium will move in a way so that it can again decrease the pressure to uh, keep the same pressure, or can keep the equilibrium in the same state. So again, we have to look at the balanced equation here. From here we can see that 1 molecule of A2 reacting with 2 molecule of B to produce 2 molecule of AB. That means 3 molecule are producing 2 molecule. That means if the volume is decreased and the pressure is increased, that means the reaction will go in a way where there are lesser number of molecules present, and that way it will be able to minimize the change or the decrease in the volume. So that means when volume is decreased, the reaction goes in a way or in a site or favors a site in which site there are lesser number of molecules present. So from here we can see that we have lesser number of molecules present in the product site or in the site of AB. That means if we decrease the volume, the reaction will go in the right direction or will produce more AB to the minimize the effect of the decrease of volume. That means decreasing the volume will increase the number of AB molecules in this reaction mixture.